In section 5.2, we are working more with exponents and scientific notation. So we have the power rule and the power of a product or quotient rules for exponents. So if a and b are real numbers and m and n are integers, then a raised to the m raised to the n is equal to a to the m times n, which is the power rule. If I have a times b raised to the m, I can raise each one to the m and get a to the m times b to the m. That's the power of a product. And then a over b raised to the n can be written as a over n, a to the n over b to the n, where b is not equal to 0. So for the last two rules, essentially what you're doing is you're distributing the power to each piece. And if you have a power raised to a power, then you multiply the powers. So let's go ahead and use the power rules to simplify the following. Make sure we only use positive exponents when we write. So we have 5x squared cubed. This means that every single piece needs to get a cubed power. It's like we're distributing the power. So we have 5 cubed, and then we have x squared cubed. Well, 5 cubed is 125, and I have a power raised to a power, which means I need to multiply the powers together. So we get 2 times 3, or we end up with 125 x to the 6th. Let's try another one. We've got 3p to the 4th over q to the 5th squared. So that means that every single piece needs to be squared. So we have 3 squared, we've got p to the 4th squared divided by q to the 5th squared. And so on top we end up with 9. And again we have a power raised to a power, which means this is going to become p to the 4th times 2. And on the bottom we have power raised to a power again. That's q to the 5th times 2. And so on top we end up with 9p to the 8th all over q to the 10th. Let's try the next one. We have 2 to the negative 3 over y raised to the negative 2. So every single piece is going to get a negative 2 power. So we have 2 raised to the negative 3 raised to the negative 2. And on the bottom, we end up with y raised to the negative 2. Well, on top, we have a power raised to a power, so we're going to multiply. And negative 3 times negative 2 actually gives me a positive 6. And on the bottom, I still have y to the negative 2. We don't like to write negative exponents, so anything raised to the negative exponent needs to be flipped across the fraction bar. And we know that 2 to the 6 is 64. And now I have y squared on top. Let's try another one. X raised to the negative 5, y squared, z to the negative 1, all raised to the 7th. So every single piece is going to get a 7th power. So that's x to the negative 5 raised to the 7th. That's y squared raised to the 7th. And z to the negative 1 to the 7th. So when we multiply these powers together, we end up with x to the negative 35, y to the positive 14, and z to the negative 7. We don't keep negative exponents, so we need to move some stuff around. X to the negative 35 is going to be flipped down, and so is z to the negative 7. The y is going to stay on top, so we still have y to the 14th on top, but on the bottom we now have x to the 35 and z to the 7th. And so in the chart below, I have summarized all of the rules for exponents from the first section and this section as well. So this is a great reference table to kind of keep for your back pocket. So let's go ahead and simplify some more. We're going to really combine all of these rules together. We have 2x to the 0, y to the negative 3, raised to the negative 2. So you know the drill. We need to distribute the negative 2 power to all three pieces. We've got 2 raised to the negative 2. We've got x to the 0 raised to the negative 2. And y to the negative 3 raised to the negative 2. Well, we know anything raised to the 0 power is 1. But let's go ahead and simplify our exponents a little bit. We've still got 2 to the negative 2. 0 times negative 2 is 0. And y is going to be raised to the positive 6. I've got a negative exponent on my 2, which means this needs to flip to the bottom. We know that x to the 0 is just 1, so we really don't need to write it. And so what I have left on top is y to the 6 over 2 squared, or y to the 6 all over 4. Let's try the next one. We've got x to the negative 5 over x to the negative 2 raised to the negative 3. We need to distribute the negative 3 power to both pieces. So we've got x to the negative 5 raised to the negative 3 all over x to the negative 2 raised to the negative 3. When I multiply these together, I end up with x raised to the 15th over x to the 6th. And then I can use the quotient rule to simplify. So we have 15 minus 6, which is just x to the 9th. And the last one. We have 5 raised to the negative 2, x raised to the negative 3, y to the 11th, over x squared, y to the negative 5th. So let's go ahead and look at the numbers x and y's. So we're just going to have 5 raised to the negative 2 hanging out because there's no other numbers involved. But for x's, let's go ahead and use the quotient rule. So we're going to have x raised to the negative 3 minus 2. And y, we're going to have 11 minus negative 5. Well, we know with 5 to the negative 2, we need to move this to the bottom. So we have 1 over 5 squared. For x's, we're going to have x raised to the negative 5. And for y, we end up with a double negative, and we end up with positive 16. Well, we're super close to being done. We need to move the x down because it's got a negative exponent. And so what I have left on top is just y to the 16th. And on the bottom, we have 25 and x to the 5th.